All right, so you're going to be writing this down. Henry tosses a ball straight up with a speed of 30 meters per second from a height of 1.5 meters above the ground. I need you to go ahead and write that down for me. These are our notes for today.
1.5.
1.5. So the first part is, what is the highest point in the ball's trajectory? The trajectory means all the way, its motions. So in this case, first thing we need to do is sketch it. So if this is my ground, there's my ball. We know it's going to be thrown straight up. We don't know how high it's going to get, but we know at some point it's going to return back. It's going to fall. And I know that this distance is 1.5 because someone's holding it at 1.5 meters above the ground before it's thrown up. So its highest point in the trajectory, we measure height from the ground. So our schematic looks like this. I know that my initial velocity is 30 meters per second. We know that when that ball reaches a very tippy top of its trajectory, just for a fraction of a second, the velocity is 0 meters per second. We know that acceleration is due to gravity, which is negative 9.8 meters per second squared. So now we can solve for the distance. I'm going to use this equation because I do not have time. So A equals BF squared minus BI squared over 2D. And I have to plug in what I don't know, or what I know. And it's going to look like that. Okay, so I'm going to simplify this a little bit. Negative 9.8 equals negative 300, because 30 squared is 300, over 2D. $900, not 300, sorry. That would make a lot more sense. All right. First step I gotta do, I've got to get rid of those fractions. I hate fractions. I've hated them since 4th grade. So I'm gonna cross multiply. Negative 9.8 times 2 should be negative 19.6, and I gotta carry that D with it. 900 divided by 19.6 is our next step, because we got to get d by itself. Flip that. Nope, flip it. So I got to take 900 divided by 19.6. So I'm going to divide both sides. 19.6 divided by negative 19.6. And someone check my math. I believe negative 900 divided by 19.6 should give me 45.9. Sweet. Yes.
I'm having trouble. Is 9.8? I know it's always the acceleration, but how can I tell if it's negative or positive?
It just depends on what you're. It's always directed downwards. It's directed towards the center of Earth. If you are solving for something like time, you don't necessarily have to have it, because you can't get negative time. But in this case, I'm solving with velocity and stuff, so I'm using that negative. All right, so it travels It travels 45.9 meters from where it was thrown. That is not my total height. My total height I have to add in 1.5 because it traveled 45.9 from here to here. I need the total height. 45.9 plus 1.5 gives me 47.4 meters. It's not awful. So then we can solve for how long did it take to get to the highest point. We could use either one of our acceleration equations with time in it. The one I'm using is just because, like, I always worry if I got the first part wrong, I don't want to use that answer if I don't have to, just in case. But they should always give you the same answer. So I'm going to go acceleration equals VF minus VI over time. Once I plug everything in and simplify, it's going to be negative 9.8 equals 30 divided by t. Hate fractions. Put this over 1. I believe 30 divided by 9.8 should be 3.06. Can someone check that for me, please? 30 divided by 9.8. 3.06?
Yes.
Sweet. So it took 3.06 seconds to get to that highest point. It could even ask you, how long does it take to get caught if it's caught at the same distance? In that case, it would be ask you, what's this whole part right here? We talked about this on Friday, but you remember time to go up to the highest point equals time to go down to the highest point as long as it's caught at that same height. So the total time would be 6.12, I believe. That's math in my head, but it's going to be double that. Any questions over this? It's pretty simple, right? The important part is to actually break them apart.